All right, so today I plan on covering two different types of equations. So again, I'm trying to stick with what we are working on. So this week we had modeling with quadratic equations, and then we went into modeling with rational functions. So if you're behind, then you'll get to these. If you're ahead, you're probably working on rational functions right now, unless you're really ahead. So somewhere in there. So let me go ahead and talk about these. Like sometimes because they're wordy, you guys are like, I just don't know where to begin. And you read the questions and you're like, I don't even know what they gave me. And so I'll give you some ideas or some ways to look at these questions. And I know it's always like when we do things together, you're like, oh, it's so easy. And then you try it on your own and you're like, again, like I don't know where to begin. So that's part of a skill is like being able to take out the information that's needed and not let all the words get to you. So it's practice. Okay, so if I look at example 1, it says a quarterback throws an incomplete pass. The height of the football at the time t, so I'm like, okay, time t, they're giving me this, is modeled by this equation. So h of t is equal to negative 16t squared plus 40t plus 7. It says rounded to the nearest 10th. Solutions to the equation when h of t is 0 are going to be these two. So these two is what they're saying are the solutions when h of t is 0. Which solution can be eliminated and why? So a couple of things that you could do. First off, if you wanted to, you could go ahead and you could graph this in your Desmos. You don't have to graph it even by hand. So you could graph this in Desmos, so you could get an idea what the graph looks like. But I already kind of know what this graph looks like without even doing that. And more importantly, if I'm going to have a graph, I want to know what it looks like. Like I need to know what do my X and Y axis even represent. So when I look here, you guys are like, well, wait a second. There was no X and Y. Well, remember when we solve a quadratic, we always have it set equal to our Y. So this H of T is really just our Y value. And this value of T is representing that X axis. And I really don't like how the screen goes in and out every time I write. So I don't know how to fix that. And I'll have to play with that and see if there's some type of setting. Okay, so what is this telling me then, if that's the case? Well, what this tells me is that this axis right here, my X, is my time. This is going to represent my time, T. And my Y-axis is what we say is our H of T. And that H of T, it says the height of the football at time T is modeled by this. So that H of T is representing the height of the football. So again, knowing what my axes represent. So this is going to represent my height of the football. So I haven't even looked through what they're talking about here yet, because I want to, again, understand what does the data represent. So even when I don't even need to know the exact graph, but I do need to be able to understand what is my values representing. So just even writing out this basic graph of information helps you guys to figure it out. So it also tells me, though, that when h of t is 0, so in other words, when y is 0, so I'm on my x-axis, so this h of t is saying when y is equal to 0, then these are going to be my values. So these are going to be those t values or the values on your x-axis. So we have one at negative 0.2 and at, let's say, 2.7. And this is in seconds. Our units are seconds there. Now, it's not to scale. That's totally fine. So here's what I'm talking about. Here's what's going on, though. Some football is thrown. And this football, when it's thrown, so this is a negative. If that's a negative, that means that it's going to open down. So kind of a little bit of a review. If it's positive, then my parabola opens up. So if it's negative, the parabola is going to open down. So this football is thrown and it goes through these 2 points. Okay. First off, this is where the ball is going to be thrown from. So when I throw the football, it's going to go up and then come down. How do I know that? Well, if I'm about to throw the ball, and as soon as I let go, then I start counting the time it's up in the air, right? As soon as I throw it and let go, I'm counting that time. So when that happens, let me grab a different color. Sorry about that. So when I let go, my timer's starting. We hit that start time on the stopwatch. So from here to here is when I let go of the ball, and then it hits the ground, right? But when I'm here, I'm at my t is equal to 0, and this would be 0.01 seconds and so on until it hits the ground at 2.7 seconds. Now, as I'm bringing my arm back, am I counting backwards in time? No. Can I ever get back here to this negative 0.2 in time? When I throw the ball, that's when I start counting, but there's no way to go back in time. I mean, there's things that we wish we could go back in time and redo and not make that same mistake, but we can't. We can only go forward in time. So when we're talking about time, I can't have anything that's going to be over here. I can't have this negative time. That cannot happen for time. So when I kind of go through and I'm looking at the values that they gave me, those are some things that I know. So when I go through here, it says the solution negative 0.2 seconds can be eliminated because time cannot be negative. That is true. That's the correct answer. Because again, we can't have a negative time. As soon as we start counting, it's only going forward. It's only going to be positive. The solution negative 0.2 can be eliminated because the pass was not thrown backwards. Well, even if I took the ball and I went to go throw it forwards, but you know, I dropped it, I'm a girl, it didn't go the right way, the timer was still counting to go until the ball hit the ground. So it didn't matter if I threw it over my head because the timer was still counting. And if we're counting, we're only counting up in time. So it's never going to be negative. So it doesn't matter if the ball was thrown forwards, backwards, up, or straight at the ground. It's still counting time in a positive. So this direction does not matter. The solution 2.7 can be eliminated because the pass was thrown backwards. No, that's just counting the time. So again, knowing that it's just counting time should help you eliminate. It doesn't matter throwing backwards, forward, straight to the ground. And the solution 2.7 can be eliminated because the ball cannot be in the air for that long due to gravity. No, I mean, I don't know how long I'm be in the ground anyways if I threw it or till it hit the ground if I threw it, but stronger people can throw it for longer, weaker people would be shorter. It doesn't have to do with gravity, it has to do with that initial push of it, throw of it. So that doesn't matter. That's no reason why that couldn't be an answer. So again, just understanding some of these, you guys like, none of those make sense. Like if you understand what's going on here, then it's easy to pick the correct answer. Questions before I move on. So if you happen to have questions, you can put it in the chat or unmute. Otherwise, I'll keep going, but I don't want to go too fast. Otherwise, I will go to the next problem. So this is focusing on quadratic equations. So all of them are going to be your parabolas. This next example has to do with rational equations. And as a little bit of a review, when we talk about rational equations, something that comes in helpful when we talk about our rational equations. So I'm going to do a little, what I say is a recall, because it's stuff that you've already learned. It was in Math 3, maybe they reviewed it already this year for you as well. But when we talk about our horizontal asymptotes, so remember, asymptotes are going to be lines that the graphs come super close to touching, but they never touch. So horizontal are going to go across the horizon. So they're always going to be, because it's going across the horizon horizontally, it's going to be cutting through your y-axis, so they're always a y== equation. And there's different scenarios. There's 3 different scenarios. So when we talk about horizontal asymptotes, we need to look at the degree. Look at the degree of your numerator and your denominator. Okay, so there's 3 scenarios. Either the degree of your numerator is going to be less than the degree of your denominator. So if the degree is less than, then your horizontal asymptote is going to be y=0. Second scenario is when your numerator is equal to your denominator, then your horizontal asymptote is going to be y equals a over b. Well, this part's kind of tricky for some of you guys. What does that mean, that a over b? Let me zoom out on this just a smidge because I'm going to run out of space here. Okay. Okay, so when I talk about my a over b, these are going to be the leading coefficients. And I'll talk about more about this in a second. Okay, and then my last piece, my last option, option 3. So my numerator is less than denominator, they're equal, or my numerator is going to be greater than my denominator. So we're looking again at the degrees. Then that means that the horizontal asymptote is going to be oblique. Sometimes they refer to it as a slant. So it just depends on the textbook. And when we do that, that's when we want to use our division. So when we want to find that, we use our division, whether it's synthetic or long, depending on if it's going to be a linear equation or not. I don't think they go into details about it in this unit. Later on, we will definitely learn more about doing this, but I'm pretty sure you guys haven't had this yet. So I won't go too far into that. Okay, so let's look at our actual equation. What does it say? What is it telling me? Okay. So what this tells me is, I'm going to zoom back in so that you guys can actually read the words on the paper. Okay, so what this question says is that I'm given this function f of x, and it yields an average cost in dollars. So the function yields an average cost in dollars for a company to produce X calendars. So I already know what my x-axis is because it's using X this time. That's great. So over here, I know that my x-axis is representing my calendars. So my y-axis, which is my f of x, is representing the average cost in dollars. So this is going to be my average cost in dollars. Average cost in dollars is my y-axis. Okay, so it says, which statement best fits the situation modeled? Okay, so again, I could do a couple things. I could plug this into my calculator and look at it. But before I even do that, and again, I'll show you that just because I want to make sure to expose you to that. I want to look at things that are important because what happens here is that I should know that this is a rational expression where it has a term divided by another term. So when we look at these, we have a polynomial over a polynomial. That's what makes it a rational expression. And so I say you need to focus on the degree. The degree is the highest term. So here is a 600 plus a 2x. This 600 is degree 0. The 2x is degree 1. How do I know this is degree 0? This is like saying 600 x to the 0 power. Anything to the 0 power is 1. So that's just going to be, that would be a degree 0 then, and this would be a degree 1. And this is also degree 1. So the highest degree is a 1 in the numerator and a 1 for the denominator. So the degree of the numerator is equal to 1. Degree of my denominator is equal to 1. So the numerator is equal to my denominator. The degree of my numerator is equal to my denominator then. And if that's the case, then if I want to know what my horizontal asymptote is, oops, then y is equal to, and I say a over b. These are the coefficients. When I say leading coefficients, it's the coefficients of that highest degree. This is not written in standard form. Standard form for this would be 2x plus 600. So it's the leading term would be that 2. This leading value, or the value right here, represents my a. This would represent, that imaginary 1 would represent my b. So I would say my slope then is going to be 2 over 1, right? So my slope, or my line there is y equals 2. My asymptote is y equals 2. So here at the value of 2, y equals 2, I would have an asymptote. That means that I have a line that cannot be crossed. I have a line that cannot be crossed. So let me go ahead and share really quickly my calculator. And I actually already have it in here. So when I first put it in, my screen was like this, and I'm like, I don't even see the graph. And I had this like asymptote here at 2, and I'm like, I see nothing. And so I zoomed out and I'm like, oh, there's my graph, and I can see my rational expression here. And I can also see this line right here, and look how close it's getting to that x-axis. And do you want to know how close it's actually going to get? It's going to get as close to that value of positive 2 that it can, because it's going to get super, super close to our asymptote. So I can see this, and I could zoom out, and I can again see how close it's getting to these values here. All right, so this just kind of gives me my general idea of what my graph would look like. So let me go back to my thing here. So I know then my graph is going to go something like this, and we would be like this. Okay, so I need to answer some questions then. So I look here and go, well, what are they looking for? And it says that the company spends $600 on a new computer and printer before beginning the project. Okay, so let me ask you this. If they're beginning the project, how many calendars have they sold? 0, right? They haven't sold any. They're gonna print to sell calendars, and I'm looking to see how many calendars, and they haven't sold any then. So if they've sold 0 calendars, then X would be 0. Why do I care about that? Because if my X is 0, then my F of X, or the cost, is going to be what? So I could look here, go back to my graph, and I can look here at 600, and I could zoom in specifically right here so I could try to get it better. And it's looking for your cost here. And so I'm getting close, but I'm not getting it exactly on. So I could see, ooh, it looks like it's about a value of 1. So like I could go plug it in and I can see what we're going to get. But look here, so if I go, if X is 0, I'm going to go up close to there. So when I go in and I plug those values in, I have 600 plus 2 times if X is 0 all over my 0. Ooh, that doesn't work, because what happens? It's undefined. It's undefined. Huh. Okay, so that's what's going to throw you guys off, because then you're like, oh, well, if I don't sell any calendars, then I can't solve the equation. Okay, so let me ask you this. What if I'm working to get to that value of 1 calendar? What if I'm working to get to that value of 1 calendar? So what if X is going to be 1? Now, even though I haven't sold one, but I'm working towards that value of 1, where am I going to be? So F of X then would equal 600 plus 2 times 1 all over 1. That's going to give me a value of $602. So I know then that that's going to be a value of 600. When I sell 1 calendar, I'm going to get $602. So I'm not there. Remember, I haven't sold that one, but I'm on that process. So the reason why this doesn't show up is because you have a vertical asymptote at X is equal to 0. Remember, for vertical asymptotes, you look at your denominator. Oops, sorry, it's blurry. You look at your denominator to see what's going to make it undefined. In this case, it's when X is equal to 0. So I could have plugged in a value of 0.5 and it would have been 601. So I needed to plug in something that's going to be greater than 0, but your actual answer is something going to be less than 1, because when I sell exactly 1, it's 1 calendar. Question.
Excuse me, Miss Acevedo.
Yes.
We still see Desmos. on
Oh,
our
I'm
screen.
so sorry. I'm so sorry. Thank you. Thank you. I'm so sorry. It doesn't show me on mine that you're still seeing that.
Yeah,
Okay, I'm sorry.
sorry for
Thank
not
you.
letting you
No, you're
meet us
fine.
sooner.
I'm
I just didn't want to interrupt.
No, please do. No worries. I'm so sorry. Okay, can you see it back now?
Yes, ma'am.
Okay, so here's where we were if we're at 0 versus 1. This is one calendar that's going to give us 602. We're talking about we want not one calendar, but in between here because we're not getting a full calendar out. So it says, what do we need to spend? Well, this is our starting cost, and this is the number of calendars. So you can see that the company spent $600 on a new computer and printer before the project begins. Again, if we plug in x equals 0, vertical asymptote, that comes because this denominator is equal to 0, and it would be undefined. So vertical asymptotes are from our denominator. So again, this is a review. Denominator cannot be 0. Otherwise, it's undefined. So again, we have this right here, although it doesn't show it. The other option, so again, just understanding kind of what's going on here, the company, and I don't have to do all this work, sometimes just understanding what your axes are. This is just to help you guys look at different pieces of it. And I'm going into way more detail just because I want you guys to see this is where information's coming from that might help you throughout this whole section. The company takes 600 photos before selecting which one it uses for the calendar. It doesn't even talk about the number of photos it takes. That's not going to be an option. So what is this 600 representing is really what's important to you guys. So we're not talking about taking the photos yet, or does it cost for a photo to be taken? That's not even discussed in the problem. The company expects to sell 600 calendars a month. We don't know how many calendars. That's this x-axis value that's not discussed either. And it says the company will sell the calendars for $2 each. That is not true either. We don't know how much the company is going to sell it for, but the more calendars made, the lower the cost is going to be. So when we make our first calendar, it's going to be really expensive. But as I make more calendars, then you can see that the cost is coming down. So when I start making calendars, I'm at 1, 2, 3, 4, 5, 6. And as it goes on, it's going to keep coming down. So the cost that the company has, will keep coming down, but it will never be less than $2 because it has an asymptote here. So the cost that the company has is going to be always more than $2. So of course, they're not going to sell it for $2. They're going to want a profit. The more that they sell and the less that the cost comes, the more that they will make. So again, businesses in the beginning, you can see they take a larger gamble, and if they're successful and keep producing, then their costs will come down. So this is their average cost for the company. So kind of a lot of information to take in. I try to review as we go through this stuff. So that's why I add in extra information. It's more just review information for you guys to know. Because again, sometimes it's expected that you already know it in Edgenuity, and sometimes we just don't remember how to find these little things like our horizontal asymptotes and our vertical asymptotes. If you guys get other particular questions along the way, like and you're stuck or you need to review something, send me pictures of like the problem or the question or the topic, and I will respond to you guys. So you could send them out to me via email, or you can try to schedule an office hour with me as well, whatever is easier. Do you guys have any questions?
No, ma'am.
All right. Well, I appreciate you guys coming today, and if you do come up with anything, make sure to let me know.